Hi everyone, Mary here, and this problem is going to be a try this problem. What I'd like to have you do is try this one on your own, and then after you've given it a go, if you get stuck, come back and watch the video and see how it goes. So here's the problem. A jet lands with a speed of 100 meters per second and can decelerate at a rate of 5.00 meters per second squared before coming to rest. What time is needed for the plane to come to rest? So let's only do that part first. So hit pause, take a look at the problem on your notes, see how far you can get, and then come back and we'll do it together. All right, here's my situation. I have an airplane, and my airplane is coming in for a landing. It's not a shoe, it is an airplane. And the plane is landing with an original velocity of 100 meters per second. It can decelerate at 5.00 meters per second squared, so that is a negative acceleration. And it comes to a rest. Remember, when you find words like rest, that means one of the speeds, so final velocity is 0. What time is needed for the plane to come to rest? Time is question mark. And when I look at my kinematics equations and I look at those four variables, the equation I'm going to choose is VF equals VO plus AT. Now, if you did a different way, hold on, you might have gotten the right answer. I'm going to do my algebra and I'm going to solve for time. So I'm going to subtract VO from both sides. So VF minus VO is going to equal A times T. And then to get T alone, I'm going to divide both sides by A. So that's going to leave me with time is final velocity minus original velocity divided by acceleration. And remember what I said in one of the other videos, if you are not confident or strong in your algebra, when we come up with a algebraic rearrangement, put those on your formula sheet. You have to be your own best friend in physics. So final velocity is going to be 0. So 0 minus my original velocity, which was 100 meters per second, divided by the rate of deceleration, minus 5 meters per second squared. And so time, well, I can do this without a calculator. What is 100 divided by 5? Well, that happens to be 20. And there's a negative sign here and a negative sign there. Those negative signs are going to cancel. And I should end up with seconds. So let's do a little looking at the units. Make sure the units work out the way they should. Meters per second divided by meters per second squared. We're going to invert and multiply. So seconds squared over meters. Meters cancel meters. One of the seconds will cancel that one. I end up with time on top. Yahoo! I did it right. I ended up with time. So that is the time it takes for the plane to stop. Now the second part of the question says this. Can this plane land on a tropical island that has a landing strip of 0.088 kilometers, 0.0800 kilometers long? All right, same thing. Hit pause, give it a go, and then we'll go through it together. Now, the second part of the problem, what I want to find out is the landing distance required for this aircraft. So the landing distance for this aircraft is X. I know it's going to take 20 seconds to stop. I know its final velocity is 0. I know its original velocity is 100 meters per second squared, meters per second, and it can decelerate at minus 5 meters per second squared. We have lots of choices of different equations we can use. I think the one that I am going to choose is, let's see, ones that have x in them. VF squared is VO squared plus 2AX. I think I'm going to pick that one. I don't need time, but you may have chosen another one with time, and that will work. So final velocity is 0. I'm looking for x, so this is going to be VF squared minus VO squared divided by 2a is what's going to give me x. So x is going to be, final velocity is 0 minus 100 meters per second squared, please remember that negative sign is outside the square, 2 times a negative 5 meters per second squared. So this is going to be 100 squared on top is 1,000 meters squared per second squared. And on the bottom, and that's a negative, on the bottom 2 times 5, 10 meters per second squared. And so the answer is going to be x equals 1,000. I did this wrong somehow. 100 squared isn't 1,000, it's 10,000. There we go. 10,000 divided by 10, 1,000 meters is going to be the stopping distance of the aircraft. Now, a couple things before we leave this problem. This is negative, that's negative. This turns negative, that turns negative. The two negatives cancel, indicating that this is a positive displacement. The aircraft is moving forward as it decelerates, and that makes sense. Can the airplane stop on a landing strip that is 0.8 kilometers long? Well, 0.8 kilometers is, if I move my decimal, 1, 2, 3, 800 meters, and it takes 1,000 feet to land the airplane, so the answer to the second part is nope. It's going to end up in the drink somewhere, which would not be happy for anybody involved. So don't try and land this jet on this tropical island runway. Alrighty, folks. I hope you had good luck with that, and if not, keep watching. See you later. Bye.